going to solve some basic integration problems. Now we get right into it. What if you have the integral of 3x minus 1 to the 5th power times dx? Well, if you were to let u be 3x minus 1, then du would be 3 dx. That would make this piece u to the 5th. But we need 3 dx before I can write du, so we bring in a 3, so that's du, and I have to bring out the multiplicative inverse of 3, which is 1/3. That is 1/3 times 3 is 1. And this here is a simple integral. It's u to the 6th over 6. So we have u to the 6 over 18 plus c, where u was 3x minus 1. And that problem is over. Suppose you have the integral of 2x dx all over 7x plus 5 to the 11th power. Personally, I don't see any reason why we need that 2 there. And if I did, either I can bring this 2 back in, or I can put a 2 in and bring a 2 out, and that's going to cancel anyways. Sometimes you need a constant, but I don't see that yet. Okay. So, I guess we should let the bottom be u. Because right now, I can't do this division. Like if that top was more complicated, 8x cubed or 8u cubed minus 2u squared minus 7u plus 11. And the bottom was u to the 11. I can do this division now. I can do that division. But I can't do it when it's all mangled up into 7x plus 5. Okay. Turns out that if that's u, then du will be 7x dx. So I need a 7, so then I have to divide by 7. I have a typo, excuse me. The differential would just be 7 dx. So I need the 7. Let me just put it closer to the dx. And don't ask me why I divided by 2 in the front. Okay, so we have 2, 7. Let's talk about the bottom. This is u to the 11th. Okay, 7 dx, that's du. So what's x? Well, u minus 5 is 7x. Divide by 7 and now you have x. It's u minus 5 over 7. I'll bring the over 7 in front. But now is where everything comes together. We have 2 over 49. Like I said, separate the integrals. It's u over u to the 11th du minus 5 du, I'll pull the 5 in front, over u to the 11th. But these two integrals are pretty straightforward. The first one is u to the negative 10th du minus the integral of u to the negative 11th du. You add 1 to that number, you get negative 9, divide by that number, minus, you add 1 to that power, and then you divide by that power, plus c. So it's 2 over 49 times negative 1 over 9u to the ninth. These two negative signs cancel out the positive, and you get 1 over 10 u to the 10th plus c. And there is your answer. Once we called this u, yes, the x became more complicated. Now it's u minus 5. But now I can do the division. I can divide the u by the u to the 11th. I can divide the 5 by u to the 11th. Before I couldn't. Integral of x sine x squared dx. Unless the angle is u or v or t or a, if it's more complicated than that, I would let u equal the angle. Then du will be 2 dx. Well, sorry, du would be 2x dx. Well, I have the x dx. Let me slip into 2. So everything underlined, well, there's the half. Everything underlined is du. This here is sine of u. But I know that integral. The integral of the sine of u is negative cosine of u. So the final answer will be negative 1/2 cosine of u plus c, where u is x squared. That problem is done. About the integral of sine x e to the cosine x dx. Now the angles are just x, so we don't have to make a substitution change there. I would call the power of e u. Let u equal to cosine x. And then du is negative sine x dx. So this piece is e to the u, and this times that, well, only if I had the negative. So I can put the negative and bring out a negative. So this piece times this piece, namely this, is du. But that's the simple, with a minus in front. That's the simple integral. The integral of e to the u du is e to the u plus c. We substitute back what u is. Don't try to remember or guess at it. Read it from the paper, your page, and there's your answer. And if you don't believe this is right, take the derivative of this and you will see that you get this back without the minus sign. I mean, actually what you would get back would be all of that without the integral sign. That is, the two negative signs will cancel out. The integral of 1 plus e to the x cubed over e to the x dx. What on earth can you do here? I mean, one thing you can do is you can cube the numerator, which probably wouldn't be the worst idea. But how about we get bold and we let u be e to the x, so then du will be e to the x dx. So clearly the denominator is u, the numerator is 1 plus u cubed, and then dx, Well, if I had an e to the x, then I can call that du. But that's not a problem, because I can put an e to the x in the bottom. I just can't put variables inside the integral and outside the integral. And that's u. Okay, let's look at this again. We have 1 plus e to the x over e to the x. If I multiply top and bottom by e to the x, well then u is pretty simple. It's e to the x. And then I have my e to the x for du. That's for my du. And all the other e to the x's cubed, all the other e to the x's become u. Like this, it becomes 1 plus u cubed. This becomes u times u, which is u squared, times the other u. I'm glad I did it again. Okay, now I would cube 1 plus u. And using Pascal's triangle, we know that it's 1 plus 3u plus 3u squared plus u cubed. And then I divide each and every term by u squared. So the first one gives me u to the negative 2. The second one gives me 3 over u. The third one just gives me 3. And the last one gives me u. So the first integral, I add 1 to that power, and I divide by 1. The reason I didn't bring the u to the top is I know the derivative of du over u. There's the 3. Remember, we have the integral of 3u du, but I can put this 3 in the front, and this integral is just, let me try that again, please. If I have the integral of 3 over u du, I can pull the 3 out in the front, and I just have du over u. But I know that integral. It's ln of u, absolute value of u. So 3 ln of the absolute value of u. The integral of 3 du is just 3u. The integral of u is u squared over 2 plus c, and u was e to the x. Well, that's negative 1 over u. That's how I write u. Plus 3 ln of e to the x. E to the x is never ever negative, so I don't need absolute value bars. Plus 3 e to the x plus e to the 2x over 2 plus my constant. Okay, and that is the integral of the beginning problem. This problem without the e to the x inserted. Here's an easy one. Easy because it follows one of the rules that you're supposed to know. The integral of secant of 7x times the tangent of 7x dx. Like I've been saying, I would let u equal an angle if the angle was more complicated than u or v or t. It's 7. It's not just the letter. It's 7 times the letter. So then du will just be 7dx. So if I put a 7 here, I'll have 7dx, and I have to bring out 1/7. So this becomes secant u, tangent u, du. Secant u, tangent u, du. And that integral is secant of u plus c, and just type in what u is, Don't guess, it's 7x plus c. Here's your fairly simple integral, 7x dx over 3x squared plus 4. Again, I'd bring that 7 in front. Even when I wrote down the problem, I'd put it in front. If I let u equal the denominator, then du is 6x dx. If I put the 6 in and I bring over the 6 outside, I'm done. This is u and that's du. I have 7 over 6, du on the top, u on the bottom. I remember this integral. You have to remember some integrals. You don't have to remember this integral, but you have to remember this one. This is 7, 6 ln of u, which is 3x squared plus 4, which is always positive. So you don't need the absolute value bars. I know that x squared is at least 0. If I multiply both sides by 3, I get that. And then if I add 4 to both sides, I get that 3x squared plus 4 is at least 4. That means it's bigger than 0. If you're at least 4, if you have at least $4 on you, if you're at least 4 years old, if you're in at least 4th grade, you have more than $0, you're more than 0 years old, you're more than in 0th grade, you're more than 4. If you're more than 4, you're positive. The absolute value of a positive number is that number. You don't need the brackets anymore. Let's try one more. Integral of x dx all over 4x to the 4th plus 9. You might be tempted to say the bottom is 4x to the 4th plus 9, or maybe without the 9, but it doesn't matter because whether the derivative of 9 is 0 anyways. So whether you have the 9 or not, du is going to be a multiple of u cubed dx. You don't have x cubed. I mean, sure, you can multiply by x squared, but then you're going to have to multiply the bottom by x squared. And that's not going to work like you did with e to the x. Okay. So believe it or not, we're going to let u equal 2x. But let's motivate it first. The denominator is the sum of squares. 2x squared plus 3 squared. Like I said, now I'll let u equal 2x. So then du is 2 dx. I take that back, please. (4x to the 4th) is 2x squared dx. 2x squared squared. This here is 2x squared squared plus 3 squared. Okay, I'm going to let u equal to 2x squared, then du will be 4x dx. If I slip into 4 and I bring out a quarter, then that numerator is, well, there's the quarter, that numerator is du. And the denominator, well, that's u squared plus 9. This is an octant if you remembered. If you don't remember, both of these terms have a plus in front. So the square root of that whole thing goes on one side, and just the u, what's being squared, goes on the another one of the legs, and just what's being squared, namely the 3, goes on yet another leg. Now, call the angle V. The tangent of V, okay, so what did I do wrong? The square root of u squared is u, not u squared. The tangent of V is u over 3. So this helps me get du. So I have du. Now I need u squared plus 9. I can square both sides and add 9, or I can say this divided by that is pretty good. Secant of V is the square root of u squared plus 9 divided by 3. I'll put the 3 on the other side. Now, if I square both sides, then I get u squared plus 9. Okay, so I have 1/4 du is 3 secant squared v dv, and u squared plus 9 is 9 secant squared v. The secant squared v's cancel out. 3 goes into 9 3 times, and I'll pull out the 3. 4 times 3 is 12, and we're just left with the integral of dv, and that integral is v plus c. Now we substitute back. What is v? Well, I would come right here. Let me write it down here. 3 tangent v is u. Dividing both sides by 3, I get tangent of v equals u over 3. Now, I can interchange those two whenever I like, as often as I like, as long as if there is no inverse, I put an inverse. If there is an inverse and I switch them, I don't put an inverse. This is what v is. Okay? So let me just give myself a little bit more space. It's 1/12 of v, which is the octant of u over 3 plus c, and u is 2x squared. So it's 1/12 octangent of 2x squared over 3 plus a constant. That is the integral. And that's going to finish this section.